Alright, so I'm looking at another equation, and I meant to identify the solution set as a shape. And honestly, I looked at this and I simply did not remember what shape the solution set to this equation is. So I am working through it. I'm trying to construct some argument. I'm trying to figure it out and argue that I know the shape at the same time. So what I'm going to do first of all is say that the solution set to this thing has intersection with the YZ plane, that is the x is equal to 0 plane. Right, the solution set to the algebraic equation in 3 variables, x is equal to 0. So that would be just points in the YZ plane, and so the YZ, the ordered pairs of numbers YZ, such that z squared plus 4y squared is equal to 4. That is, I've just removed the x term, the x squared term there. And that solution set, right, that's a solution set for this equation. That's an ellipse with eccentricities 1 and square root of 4. The eccentricity in the y direction is 1. I'm thinking about dividing by 4 to get 1 on this side. And dividing by that would also give a over 4 down there. And so the eccentricity is the square root of 4, which is 2. And then I drew that, right? In the YZ plane, I drew z-plane. This ellipse. It looks very circular to me, but I have these tick marks here. I guess the scale is different on the z-axis than on the y-axis. And then I thought to myself, how can I explore this a little bit further? If I rearrange the algebraic equation right here to be pretty close to what I had in mind with this when I divided by 4, but I kept the x square in there. So instead of dividing by 4, divide by 4 minus 4x squared, or rather 4 plus 4x squared, right, which you get by moving that guy to the other side. That would leave me with z squared over 4 plus x squared. I think of that as the eccentricity squared, and y squared over 1 plus x squared. I think of that as the eccentricity squared. And what I'm going to do then is say that this equivalent equation implies or shows that for values of x other than 1, the eccentricity is bigger. Eccentricity is bigger. Okay, so that is to say, if I come forward in the x direction here, wrong color. If I come forward in the x direction, then I will have another ellipse with more eccentricity. So larger eccentricity in both directions. So let me think of an ellipse maybe centered right there. It's going to be even more eccentric than this. So it's going to kind of shoot out as it comes towards me. I need to think about, maybe it'd be easier to take one going back, right? Going back along this. Maybe centered at this point. Eccentricity is bigger as I go back. There's going to be some ellipse. It's bigger as you go back and bigger as you come forward. And once again, I didn't have the forethought to make that guy white. So this is a terrible drawing. Really unhappy with it. What could I do to make it better? What I could do? I'm going to change where the x direction is. Make x that direction. Yeah. And so if I do that, rotate, that would bring, let's see, I have to have a right-handed coordinate system. So x, and then, let's see, if I do x and then curl into y, then the z direction would be to the side. So I'll make y coming out in this direction, y, and then z going out in that direction. That way, x cross y is z. Oh no, I did it wrong. I'll make that the z direction. Like a little quarantine for my drawing over here. And that will have to be the y direction. Do I have it now? X cross y is z. No, what am I doing? X cross y is z. So that I had it right before. Okay, so the reason I like that is because drawing this again, I have a ellipse in the YZ plane that gets bigger as I go up, and I feel more comfortable drawing it this way. It gets bigger as it gets up, and it goes bigger as it goes down also. Okay, good. So what kind of shape is this? Let's see. There was the ellipsoids, paraboloids. I don't see anything very parabolic about this. And then there was hyperboloids. Oh yes, right, hyperboloid. This is a hyperboloid, and there's the hyperboloid of one sheet, there's a hyperboloid of two sheet. So the solution set is then a hyperboloid of one sheet. Right, now this rings a bell. If I had not looked at the YZ plane, but the ZX plane, then I would have set y to 0, and I would have z squared minus x squared is equal to 4, and that would have been a hyperbola. And so what I'm looking at is a whole family of hyperbolas that go around in circles. Very cool. That's why it's called a hyperboloid, and I was exploring it in terms of ellipses of different eccentricities at different x values. If you know how to draw this better in this orientation, teach me. I would be happy to know. Thanks for watching.